The primary objectives of this lab are for the students to demonstrate a proficiency in gas and arc welding safety, setting up a heating torch, lighting a heating and cutting torch, and using different forms of air-powered metal cutting. Throughout the course of this semester, the use of many different tools will be required in order to complete your various lab assignments. The first step in using a tool correctly and efficiently is being able to identify it while also knowing its specific function. The tools used today include an oxyacetylene setup, including a heating and cutting torch, a plasma cutter, a TIG welder, a pair of slip joint pliers, soapstone, a torch striker, a file, a piece of 3/32 filler rod, a 3/32 braze rod, placeholder magnets, and an angle grinder. PPE, or personal protective equipment, required for each lab can vary from week to week. It is important to stay up to date on the PPE to meet the safety requirements. The students' PPE for this week will include closed-toed shoes, long pants, a long-sleeve shirt, safety glasses, leather welding gloves, a welding helmet, number 4 shaded lenses, and a face shield. For this lab, you'll need 5 pieces of 4x4 by 8 inch steel plate. Begin by using a piece of soapstone to draw a simple design on one of the plates. It will not be required of you to set up the cutting torch, however, you will be responsible for lighting it. First, begin by making sure the oxygen is open at the bottom of the torch. Then, open the acetylene, grab a torch striker, and strike above the torch nozzle to ignite the acetylene. Then, cut the acetylene back until the flame touches the tip of the torch. Slowly use the knob on the upper left side of the torch to introduce oxygen to the flame. Add oxygen until you can see the small buds on the torch tip. From there, the torch is ready to cut. Start by slowly heating up one line at a time of your drawing. Heat the steel plate up until the metal becomes cherry red. Once the metal is cherry red, you can then press the large lever on the back of the torch to unleash a steady blast of oxygen to blow through the molten metal. Once you've blown through the metal you heated up, release the trigger and repeat the process on the other sides of your drawing until the shape is cut out. Use a pair of slip joint pliers to quench the metal when finished. Secure the plate in a vise and use an angle grinder to clean up any leftover metal fragments from the side of the plate. Don't forget to wear your face shield. Also, use a file to clean up the interior edges of your cut. Next, take another plate and using a piece of soapstone, draw another design on it. Using a plasma cutter is a fairly simple process. On the front of the plasma, we see an on-off switch and a knob for amperage adjustment. For our use, make sure the amperage is set to 30. It also has a ground clamp and a plasma torch. Before beginning, check to make sure the air hose is attached to the back of the plasma. The plasma torch has a safety on it that must be slid backwards towards the operator before the trigger can be pressed, as shown. Push the safety backwards and pull the trigger approximately 2 inches above the surface. Slowly move the tip of the torch closer to the metal until it is about an inch away. At this distance, the plasma will begin to cut. Remember, the tip of the plasma torch never touches the metal surface. Trace around your drawing to cut the shape out. When finished, Quench this piece and use an angle grinder to clean both sides of it as well. Learning how to set up a heating torch is a main teaching point of this lab. First, turn on the acetylene tank to approximately 1/8 of a turn, or until you see the pressure jump on the gauges. The gauge on the right reads tank pressure, while the gauge on the left reads flow pressure of the line. Open the acetylene valve on the torch and, making sure you're standing off to the side of the tanks, set the flow pressure to 5. Once the pressure has been set, close the acetylene valve. To begin setting your oxygen up, first open the double-seated valve all the way on the top of the tank to ensure a complete seal. The right gauge reads tank pressure, while the left gauge reads the pressure of flow in the line. Open the oxygen valve on the torch and, making sure you're standing off to the side of the tank, set the flow pressure to 5. Once the pressure has been set, close the valve. To light the torch, make sure the tip is facing away from the tanks, open the acetylene, grab a striker, and strike above the tip to ignite the acetylene. Cut the acetylene back until it touches the tip of the torch, and then slowly add oxygen by opening up the oxygen valve. To achieve a desirable neutral flame, add oxygen until the outer and inner flames meet on the torches. Now, this heating torch is ready to gas weld. To begin welding, take your metal to a gas welding table. Using magnets as shown, set up 2 pieces of metal, leaving a 1/16 of an inch gap on top for our gas weld. Using a torch, tack the metal together before welding a full bead. To tack metal with a gas welder, heat up an area where both pieces touch evenly. The corners will begin to melt, and after a period of time, they will fall together into a puddle. Push this puddle for a second to complete the tack. Once the metal's been tacked, remove the magnets from underneath before continuing welding. To gas weld a full bead, start by heating up one of the ends of the 2 conjoined pieces of metal. Heat both sides up evenly until they fall together into a puddle. Then, using small circular motions, push this puddle along the gap, taking extra time in places where the edges don't melt as quickly. After welding, be sure to quench your metal before removing it from the table. Next, set up 2 new pieces of metal like before. With the regular gas weld, we simply heated up 2 pieces of metal, joining them together. Gas welding with a filler rod is a bit different. This time, when we see a puddle form, we will dab the tip of a filler rod into the puddle, adding more material as we progress down the weld. Don't stick your filler rod under the flame until you see a puddle form though. Don't forget to tack your metal before welding, and also after your tacks and before you run your beads, don't forget to remove your magnets. Remember, before you touch your metal, quench it first. Set up the metal as shown and then grab a brazing rod. Brazing is different than the previously covered gas welds because when a brazing process occurs, the base metal isn't melted, only the braze. Tungsten inert gas welding, or TIG welding, is another method of arc welding through a tungsten electrode. TIG welding also uses argon gas as a shielding agent. Amperage is controlled through a foot pedal. The harder you press, the more amperage you get, and vice versa. Prior to welding, clean your joint thoroughly with a stainless steel brush. To start an arc, place the tungsten electrode close to the groove and press down on the pedal. The way to TIG with the filler is almost identical to the way we gas welded with the filler. We'll see a puddle form, and then add filler to that puddle. It's very important to note that the tungsten tip does not touch the metal while the welding process is occurring. Once welding has finished, release the pedal, and hold the tip over the weld for a few seconds so the shielding gas can continue to flow over it while it cools. The bottom plate may be welded on using any process learned in this lab today.